Hello all, welcome to Code Hub. Today let us solve the LeetCode daily challenge, and today the problem is the furthest building you can reach. You are given an integer array heights representing the heights of the buildings and some bricks, and they are also given some ladders. You start your journey from building 0 and move to the next building by possibly using bricks or ladders. While moving from building I to building I plus 1, it is considered as 0 index. If the current building is height is greater than or equal to the next building's height, then you don't want to use any ladders or bricks. And if the current building's height is less than the next building's height, then you have to use either ladder or bricks. By optimally using the ladders and bricks, how far you can reach the buildings is the question states here. We can consider this image. In this image you can see that from this building he can jump to this building without using any ladders or bricks, but to this building he have to use either bricks or ladders. Here in this gif image they have used bricks, and then in next building he can jump easily, and then to the next building he can use one ladder. And as you can see that there are only maximum of 5 bricks can be used and one ladder can be used. So for this the solution is 4. He can reach till fourth building, 0 index base, so 0 1 2 3 4. He can reach till 4 buildings. So this is the question, but how we can solve this problem? We can think of some greedy approach where whenever the current building's height is greater than the next building height, we don't want to use any bricks or ladders. We can just continue. And if the current building's height is less than the next building's height, then the next building's height, then we can use either bricks or ladders. But how optimally we are going to use? We can simply greedily use the bricks, and then when the bricks are exhausted we can use ladders, right? This will be the optimum. This will be a greedy approach. We can just code this greedy approach and we can see whether it is working or not. It will not work. I will say why. We will soon code this approach. And we are having bricks and ladders, so we'll have a loop. This is going to be the n minus 1 till last before index. I will go and I will have an answer reach equal to 0, and I'm going to return reach. Here if my heights of I is greater than or equal to heights of I plus 1, we can just continue. Else we can find the difference, which is heights of I plus 1 minus heights of I. And if my bricks is greater than or equal to my difference, then my bricks is minus equal to diff. Else if the bricks got exhausted, we can use ladders. Ladders is greater than 0, then we can use ladders minus minus. Else we can just break out of this loop and come. So our answer is reach plus plus, and this will be the greedy approach. We can just run the code and see. This is not working, right? What I'm doing here is I'm just finding that whenever the current height is greater than the or equal to the next height, I will be just continuing. If the current height is less than the next building height, then I will find the difference. the next building and minus the current building, and then if the bricks is greater than or equal to the difference, then I will decrement the bricks. Else if the bricks got exhausted, then I can use ladders. Then ladders, if the ladders is greater than 0, then I will use that ladders minus minus. Else break and reach plus plus. Reach plus plus, but we have to consider this reach plus plus here, because if we give continue, it will not get counted, right? So it got accepted, but we will give some other test case and see whether this is working or not. I will give 1 5 1 2 3 4 and 10,000, and then I will give the number of bricks to be 4 and the number of ladders to be 1, and I will just run the code and show you. So here you can see that the maximum number of buildings I can reach is till 2. I cannot, but the expected output answer is still 1 2 3 4 5 till 4. Why so? Because I have not used optimally the bricks and ladders. I will take this example and show you. 1 minute. So these are the bricks and these are the ladders. What I will be doing here is I will be checking one is greater than or less than the next building. Since one is less than the next building, I have to use either bricks or ladders. According to our code, we will be using the bricks. So the difference is 4, so it will be I can reach to the next building, and then you can see the 5 is greater than the next building, so I will reach to the next building also. So the current building is 0 1 2, and you can see for the I will give the index so that it will be easy. So from 2 to 3 I can reach to the next building using one ladder, and next from 3 to 4th building I cannot reach, since I have no bricks and I have no ladders. So I have got the output as 3. But what if I have instead of using bricks here, if I use a ladder, let us check here. From 0th building to first building, if I use ladders, the ladders will become 0. Then from 1 to 2, there is no need of any ladders. And 2 to 3, there will be no need of any bricks or ladders. Since ladders got 0, I have to use bricks. So I will use 1 brick. And then from 3 to 4, I will be using 1 brick. Then 4 to 5, I will be using another 1 brick. Then 5 to 6, I will not be using any bricks, since there are many bricks to be used, and there are remaining only 1 brick left. So the farthest building I can reach is 5. So this is our answer. So we have to use optimally. So how can we do it? Is we can use some storing part. Since ladders can be used to how many ever, whatever the height is, that much height we can use ladders. So we must use the ladders conservatively, and we have to use our bricks at most very small amount. We have to waste our bricks to small part instead of wasting our big part. You can see, instead of using the bricks here, we have used 4 bricks for one building to move from one building itself. But in our next solution, we have used the bricks in 3 movements. For moving 3 buildings, we have used these bricks. So we have to use ladders conservatively. So what can we do here is we can use the bricks, and whenever the bricks got exhausted, we can check for some bricks where we used maximum number of bricks. We can change those maximum number of bricks to ladders and see, and then we can do it, right? That is, if we have used bricks, wherever we use maximum number of bricks, we can use their ladders instead of using the bricks. So we can use a priority queue here to store the bricks used. So whenever the bricks got exhausted, we will see the we will alter the bricks with the ladders. So we will use a priority queue here. Whenever one is less than 5, we will be using bricks, and we will put the difference. Consider this priority queue. We will put the difference 4, and we will move further. And you can see 5 is greater than 1. We will move to the second building, and then we should use some bricks or ladders to move to the third building. So we must use bricks, but there is no bricks since we have used before. So we can see that we can we can see whether we can change the bricks to ladders previously. If the current difference is 2 minus 1 1, if the current difference is less than the bricks used before, we are using a max heap, so 4 is greater than 1, so we will change this to a ladder. So if we want to change this as a ladder, what is we are doing is we have to eliminate this bricks, right? We have used previously bricks, so we have to eliminate the bricks. What we have done is bricks minus equal to 4, so bricks has become 0. Since we are going to alter this bricks to ladders, we will do in opposite fashion. So bricks plus equal to 4. 4 is nothing but pq dot top, priority queue dot top. And then what we are doing is current, we have to minus equal to we have to deduct the current number of bricks current difference with the bricks. And since we are replacing the bricks with the ladders, we are replacing the previous maximum number of bricks with the ladders, we will be decrementing the ladders minus. So these are the 3 lines we are going to include in our code now, such that it will get accepted. So this is the priority queue solution. Here the time complexity will be order of n log k. Here the time complexity will be order of n log k, how much hour we are storing here, and space complexity will be order of n. Okay, fine. So we have to declare first a priority queue. In this will give us a max heap to store the bricks used. So what we are doing here is, if we deduct the bricks, we will push the difference to our priority queue. And whenever the bricks got exhausted, we will check the maximum if the priority queue is not empty. If the priority queue is not empty, and if my pq dot top is greater than our difference, we can replace the current difference, right? So pq dot, so bricks plus equal to my pq dot top, and pq dot my then again I should decrement my bricks minus equal to my difference, then pq dot push. Then we have to pop the top element of the priority queue, and then we have to push our difference. So that's it. We have just included the priority queue inside our solution. Now we will just run the code and see. It got accepted. Now we will just submit it. It got accepted. Superb. That's it. Thank you for watching and let us meet tomorrow.